Hello and welcome to my tutorial about presenting data in wxWidgets using list control. In this video I will show you how to create a list view, how to optimize performance for large datasets, and how to properly handle sorting. Let's start with the basics. Here is a simple Hello World wxWidgets application, which you can download from GitHub. The link is in the description. We'll add a simple list view with a few items. A list view is a subclass of the more general list control. It's the simplest way to start with list controls, so let's start with this one and implement the most basic list in wxWidgets. We need to create our list view object and add columns. Let's add 3 of those: an ID, a name, and a description. We can also set the starting width for each column. Here we are adding a sizer to make sure the list stretches to the full window size. If you are not familiar with sizers, I recommend my sizers and splitters tutorial. After adding the list view, we need to populate it with items. Since our list has 3 columns, each item will have 3 sub-items. The string we pass as a parameter to insert item will be our first column text, and text for the next columns will be passed in setItem methods. Since columns are indexed from 0, to set the text for second column we use index 1, and for the third column we use index 2. That's the basic code for creating a simple list view with a few columns and items. We can now run our code and see the working example. Let's see how to add sorting to our list. First, we create a convenience method for adding items to make the code a bit cleaner and less repetitive. Just as before, we call insertItem to add our item and set the text for the first column. Then we use setItem to set up the remaining columns. We also add an important line, a call to setItem data. List view's built-in sorting method does not use text values to determine the order of the items. Instead, it uses a metadata passed to setItem data. This metadata is really just an integer. Here we pass the value of the ID column, which we want to use to sort the items, but we will see more complex examples of how to use metadata for sorting by any column later on. Before we get to that, let's refactor our populate list view method to make use of the new method for adding items. We got rid of some code repetition, and this now looks much better. Now let's actually implement the sorting method using the ID column. The first parameter of the sortItems function is a callback, in this case a lambda. This callback will be called by the sorting algorithm implemented in wxListView to compare 2 items. Let's take a look at the arguments to this callback. The first and second are the values set by setItem data before. So in our case, the item 1 and the item 2 will be the IDs we set earlier. The last argument is an arbitrary value passed to the sortItem method. We are using it to determine the sorting direction, which will change after every click of our sorting button. The sortItems callback should return 0 if the items being compared should be considered equal, -1 if the first item should come before the second item, and +1 if the second item should come before the first. Take a look at how we use this characteristic to determine the sorting order using our sortDirection variable. If the direction is positive, we return -1, if item 1 has a lesser value than item 2. This tells the sortItem method that item 1 should come before item 2. If the direction is -1, we return a positive value for the same condition, effectively reversing the sort order using this simple trick. At the end of the sortById method, we switch the sort direction so that after every call the sort direction will be reversed. Here we are adding the button that triggers sorting. This should do for now, since we are just sorting using one column. We are adding the button to our sizer and running the program to see the end result. The sorting by ID works correctly, and the subsequent sortItem calls reverse the order. Let's now implement sorting by column. We're starting by creating an item data object. We will store these objects in setItemData method to allow sorting not only by ID, but also by description and name. Here we are creating an item data object holding the values which can be used for sorting. We then create a pointer to this object and cast it to wxIntPointer type for storing as item data. This is all great, except for the memory management, which is incorrect. The data pointer variable is a smart pointer, meaning the data it holds is released when the smart pointer object is destroyed. Since in this case the pointer is a local variable, it will be destroyed when the addSingleItem function returns, and the data we set in setItemData will be invalid when we need it for sorting. To fix this, we could use a normal pointer, but then we'll have to remember to delete all these pointers stored in item data when our list is destroyed. Instead, let's take advantage of the properties of smart pointers. Here we create a container of smart pointers. The container is a class member, so it will be automatically destroyed when the class object is released. That will result in the destruction of all smart pointers it holds and release of all our item data objects. Next, we create methods directly related to sorting. Here is our main sort method, functions for comparing different data types, and some helper methods to be used when comparing item data objects with respect to a particular data column. In the main sort method, we just select the proper sorting call based on the column clicked, making sure to reverse the sort direction after every sort. The compare methods return zeros if the items are equal, negative number if the first item comes before the second item, and positive otherwise. If we pass negative direction argument, the order is reversed. This is the same behavior as before when sorting just by ID. The job of the different sort callbacks is to select the correct field to sort. Note that we are casting the wxIntPointer parameters back to the pointers to item data objects. We can do that because in the addSingleItem method we casted our smart pointers content, that is a raw pointer returned by smart pointers get method, to wxIntPointer. Now we have access to the original item data object, and we are able to compare data fields corresponding to the column by which we want to sort the list. The last thing is to connect the column click event with our sorting method, which we accomplish using dynamic event binding. We are now ready to build our program and demonstrate sorting by column. As you can see, when clicking the column name, we sort the items alphabetically according to the text value in that column, so it works as expected. Let's explore the concept of virtual list views. In virtual list views, we don't add items to the list directly, we instead manage the items container object by ourselves. As we will see later, this drastically improves the performance of the list, but let's not get ahead of ourselves. We start by some code cleanup, extracting the item data class to a separate file. In order to use virtual mode, we need to create a custom list control subclass, so let's do it now. We add the needed wxWidgets headers along with our own item data class. Our custom class derives from wxListControl. Our constructor calls the base constructor, passing lc virtual style parameter in order to enable the virtual mode. We set up the list columns in the same manner we did previously for the normal list view. One method we need to implement is onGetItemText, where we should return a text value for a given row and column. This will be called internally by wxWidgets whenever given row becomes visible, for example after scrolling. Here we are using the vector member variable as a data store, returning correct field for a given column index. We also have to tell the list control how many items we are currently managing, and we do that by calling the setItemCount method. Sorting virtual list view is done differently than with normal lists. We'll get to that, but for now let's remove the sorting method and integrate our new virtual list view with the rest of the code. We need to add our items to our internal data store and then refresh the list. That's all we need to create a basic virtual list view, so let's build the code and see the results. The data we see is the same as previously, but the underlying data storage mechanism is completely different. I mentioned that a virtual list control is much faster than a non-virtual one. This becomes apparent when using large amounts of data. Here is a sample application with a virtual list view listing the daily price bars for the Apple stock. Nothing new here, simply more columns and more data, along with some simple code for CSV file parsing. Let's run this up and examine the data. Here it is, 7 columns and about 2000 rows. In order to compare performance, we need another list to show the same data, this time in non-virtual mode. Again, no new stuff here, just the basic list view with more columns and more data. And a button to switch between the two lists. Let's run this up and see how much time it takes to populate the various types of lists. As you can see, the difference is huge, so it's never a good idea to use a simple list for large amounts of data. Alright, let's add sorting to our list. Because the list is virtual, we need to sort the underlying items vector and then refresh the list. As you can see, we don't use wxWidgets methods for sorting, just the sort method from C++ standard library. This method also accepts a callback, but this time we need to return true if the first argument should come before the second. As you can see, we use the same mechanics, comparing the fields for given columns and using a Boolean member variable to determine the sort order. We also bind the column click event to a handler which calls the sort method and refreshes the list. The sorting works as expected, reordering the data after column click. There is one more thing to take care of, and that is selection handling. If the user selects a row before sorting, we want to make sure the same row is selected after sorting. And if it turns out the selected row ends up in a part of the list that is not visible, we want to scroll the list to the selected item. We start with some helper methods. We need to get the currently selected index, which is done by querying the list view using the selected state mask. Also, we need to find the current index of given date value. To do this, we use standard library's findIf method, taking advantage of iterator arithmetics. Subtracting iterators will give us the integer distance from the beginning, in other words, the index of an element. Now to the main selection algorithm. Before we start sorting, we need to store the currently selected date, only if there is a selection, and unselect the item. After sorting, we find the new index of the stored date, select it back, and scroll to it using the ensure visible method. As you can see, this works perfectly. After we sort the list, we keep the previously selected date and the list scrolls, so that our selected item is visible. Okay, so why it won't work in the general case? Let's examine this example. Here we have a list of objects with two fields, name and age. The values for the fields do repeat. We have two Johns, we also have two persons aged 21. If we apply our previous approach, looking for example for previously selected name, we might end up selecting wrong item after sorting, as the search algorithm will return the first item that matches, which may be incorrect. To mitigate this problem and make our selection algorithm more general and able to handle all sorts of data without any assumptions about data uniqueness, we introduce an intermediate table. Here we store the order of which the items in the data table should be displayed on the list. So in order to get the data for a zero row, we need to check what value is stored in the zero row of our intermediate table, and use that value to retrieve the item with the same index. In the initial state, the indices and values of the intermediate table are the same, but this will change when we sort the list. Before we do that though, let's select some item and store the selected intermediate table's value. Now when we sort the items, we use a little trick. We sort the ordered indices values, but in order to determine the order of the indices, we compare the name field of the original table. So the first index value after sorting is 2, because the name John should be the first when sorting alphabetically. Then another John, index 3, then Nancy, index 1, and so on. When we display the data using the same method as previously, we get the alphabetically sorted list. We store the index 3 as the selected index. To restore the selection, we simply look for that index in our intermediate table. Since the indices do not repeat, unlike names or ages which do, we are able to identify the exact row we had selected before and correctly reselect it. Let's implement all that in code. We will need our intermediate table for storing ordered indices. We also need to recreate this table every time the items are replaced by the user of our class. We use the standard library's iota method to fill the table with incrementic indices starting from 0. As I mentioned before, we need to include the intermediate table when retrieving the data to be displayed in the given row. This is the blue arrow chain we saw in the presentation. Here's the sorting trick. We sort the ordered indices, but we use the actual data columns to determine the sorting order. Last but not least, we need to be able to find the previously selected index in the intermediate table. So here's the method to do that. The reselection algorithm is basically the same. Instead of storing the selected date, we store and retrieve the selected intermediate index. And here's the result. Sorting works correctly, and we have a general method of selection tracking that works for any underlying data structure. So that's it, thanks for watching. If you like the video, consider liking and subscribing, and I'll see you in the next one.